Okay, so this is review. We have a chapter 5-6 quiz next Thursday. It's on the schedule. Okay, so double check that. This is fair game for that quiz. Also fair game for exam number 1, which is coming up in a couple of weeks. So how you graph doesn't matter to me at all. If I just say graph, I don't care. I personally am going to use a table of values because to me it seems easier for both of these equations. If you want to use slope intercept, go right ahead. But I've got to set up a table of values for equation A. And usually I pick 0 for x. If x is 0, that means y is worth 2. And I pick 0 for y, and that means x is worth 4. Okay, so I come over here to the side and I plot those points 0, 2, and 4, 0, like that. Now I have to decide, this is equation A. I see my line right there. It's going to go there, but is it going to be a solid line or a dotted line?
Solid.
Solid.
Solid, because of the equal sign. That tells me it's going to be solid. Okay, so I'm going to do this in red, which kind of looks like this. Because there's more than one equation, you want to put the actual equation here. Notice the line is the equal part. The line is labeled with the equal part. The shading is where we get the greater than or less than shading. Now, just for yucks, I'm going to use the test point. I want to test 0, 0. Can you guys see the red, or do you want me to go back to black? I can't. Somebody asked me to turn on transcript. I can't do it. I'm afraid that that's what was causing the thing to freeze up. So I can't. I'm sorry. You guys can see the red, so I'm going to test it in the original. So that's 0 plus 2 times 0 greater than or equal to 4. Oh, this is a cool question. So this becomes 0 is greater than or equal to 4. Now, that's false. So watch carefully, please. My test point, 0, 0, relative to the red line. So 0, 0 was below the red line. Below the red line was false. 0 is not greater than 4.
Wait, I have a question.
Yeah.
Why did it switch to greater or equals to?
Because I'm an idiot. Okay. Is that a good enough answer? Damn it. So now it's true. Shit. I mean, darn it. I'm not supposed to say those things. Better? I'm sorry. I don't know. So I shouldn't have switched. And 0 is 0 greater than 4? No, I didn't switch this one either. Dummy. Got to switch this. Come on. Switch everybody, Foster. 0 less than 4. That's true. Okay. So since my test point was true and it's below, I'm going to write below here. Okay. Then I come back and I'm going to erase this to make some room. Come back and do equation B, but I'll do it with my green pen. This is equation B, and that's x minus y. X minus y equals 1. Again, use a table of values. This is going to be a bad night. I'm screwing up everywhere. So if x is 0, be careful. If x is 0, we have negative y equals 1, which means y equals negative 1. Be careful on that arithmetic. And if you need me to show that better or slower, I will be happy to. If y is 0, then x becomes positive 1. So we have 0, negative 1, which is right here. And we have 1, 0, which is right here. So I can see a line being formed. But this time, because it's greater than, I use a dotted line. And again, the line itself is x minus y equals 1. The line is always an equal sign. Whether it's dotted or solid doesn't matter. Okay, doesn't matter. Dotted or solid, when you're putting the equation of the line next to it, it's always with an equal. The shading is where you take care of the greater than or the less than. So once again, let's test 0, 0 for the green line. Test 0, 0 for this one. So is 0 minus 0 greater than 1? So we're plugging 0, 0 into the second equation. So is 0 greater than 1? That's false. Okay, now we got to do some thinking. Okay, we got to do a lot of thinking. So relative to the green line, 0, 0 was false. So look where my finger is pointing. My finger is false. My finger is above the line. So where is truth? Where would be true? If my finger is pointing to a false above the line, where's truth?
On the other side of the line.
On the other side of the line, below the line. Okay, below. Okay, so now I want up here, I want to be below the red line and below the green line. That's what I've indicated. That's what my notes say for my final shading. Now, you may have done it differently, and we arrive at exactly the same answer, and that's fine. No problem with that at all. Okay, but I want to remind you the other ways of graphing: build a table with intercepts and test points. So anyway, we want to be below the red line, okay, all below here, and at the same time below the green line here. So the actual answer to this, the shaded part that we've been ignoring, is all down here. You guys might have used slope intercept, got the same answer. Doesn't matter to me how you got this one. Is that okay with everyone? Any questions? Okay, then we'll do another one. Okay, this is being recorded, I think. Yeah. Is it? Yes, it is. So we'll do a second one unless anybody's going to yell at me. I'll erase this. Okay, here we go. Second problem. Same instructions, solve the system. First equation, x plus y less than or equal to 3. Second equation, x greater than -2. About 2 minutes to work on that one. Okay, so I'll call this top one A, and we'll start trying to graph it. Again, I see that that would be easier to graph if I just used a table of values. So if x is 0, y is 3, and if y is 0, x is 3. That's pretty simple. If x is 0, it drops out, so y equals 3. If y is 0, the y drops out, so x equals 3. So we come over here real quick. Okay. 0, 3, 1, 2, 3 is here. And 3, 0 is right about there. So this is the red line, and it's solid. So it looks something like this: x plus y equals 3. Okay. One more thing we have to do is I have to pick a test point. I have to figure out where to shade. By the way, guys, what in this problem, if I just said these instructions, systems of inequalities, and I put this problem on here, what in this problem tells you that you have to shade? Because shading may not be in the instructions. You're supposed to know this. So what is telling you in the problem that you're going to shade somewhere?
It said when it tells you to solve.
Okay, that could be the point where they cross also. Because remember, if we had this x plus y equals 3 and x equals -2, then because of the equal sign, that tells us figure out where the two things cross. So solve by itself isn't quite enough information. Solve means find where they cross. And we want
Less than, greater than?
excellent. That's the answer. The less than greater than tells us somehow we're going to shade. That's the clue, the less than greater than. Now, again, I'm real big on the dumb test point. Some of you figured out how to avoid it. Well, again, we're going to test 0, 0. So we go 0 plus 0 is less than or equal to 3. This time I got it right. So 0 is less than 3. It was true. So my test point relative to the red line, there's the red line. Here's my test point. It was true. That tells me everything downward is also true. So I'm going to write the word below up here just for a second. So on the red line, I'm going to shade below eventually. All right. So now let's do, okay, the other line. Uh-oh. The other line. X equals -2. It's a trick question. What's wrong with that? You've got to know how to graph that one, guys.
No, why?
Know why. So somehow or other, that's a hint that this is a trick. What this is saying is X is locked in at -2, and Y can be anything, 0, -7, 5, whatever. But when you graph that, here's -2, 0, okay, -2 something, -2 something, okay, it's going to be a dotted line, a dotted vertical line, and this is X equals -2. Okay. But now I have to figure out where do I shade? Well, actually, you could use a test point, and it's not wrong, but think about this. X is bigger than -2. This is where X equals -2. Which way is bigger than -2? That way. Okay, that way. That's what that's saying. So instead of seeing this as, oh, pure math, X is greater than, think bigger than. X is bigger than -2. So there is -2 right there, bigger than this way. So on the green line, I'm going to go to the right. Okay, now put it all together. I want to go to the right of the green line, and simultaneously, I want to be below the red line. Below the red line to the right of the green line. when I see that, okay, it's telling me this region right in there is my answer. Yes or no? Is that okay with everybody? Okay. Can you hear me? Is the audio working? Do I know you're alive?
Yes.
Oh, thank you. Good. Whew. Okay, I was getting worried there. Okay. That's it. Okay. I want to do a quick overview of chapter 5, then jump into chapter 6. I have something I want to do in another screen, but I'm afraid to do it because I'm afraid everything will freeze up and I'll lose you guys. So as long as this thing is working, I'm going to keep teaching up here until it freezes, and then I'm going to get really mad. So, chapter 5. Chapter 5 is all about systems. Okay. We learned systems of equations. Okay. And we have 2 by 2 equations. And we learned a bunch of ways to solve those. One was graphing. Another was called substitution. And another is called addition, elimination, or just plain elimination. And ultimately, we're looking for the point of intersection. That's our goal on all of these, whatever method we use, graphing, substitution, addition, elimination. We're always looking for the point of intersection. And that leads us to, there are 3 kinds of answers. There are 3 answers. Okay, there's normal. Okay, and normal looks like this. And that says, oh, the solution, remember the funny braces is math talk for, hey, everybody look here, this is where the solution is. The solution is this point, that's the ordered pair, the parenthesis, of 3, 1. That's where the graphs would cross each other. That's what it's trying to say. The graphs would cross each other. There is also weird number 1. I'll come over here. If there's normal, there's weird. There's weird number 1. Okay. And that's what happens if you're doing your algebra and you get 3 equals 7. Okay. Well, this is false for sure. Okay. And that means my lines were parallel because parallel lines never intersect. So you're doing it algebra. We've already accepted graphing sucks. Unless the instructions tell you graph, you don't want to graph. Graphing's really cool for the visual, but terrible for speed and accuracy. Okay. So if you're doing some algebra and you get something like 3 equals 7, you're going, WTF, what the heck is happening here? That's totally wrong. Well, that meant the graph was parallel, and that meant that you have no solution. or I prefer, but won't nick you on it, the solution that has nothing in it, nothing, because they don't cross. This, remember, says they cross and hit at that point. This says they don't cross anywhere. They don't hit anywhere. But anyways, that's weird number one. Okay. Weird number two. Okay. What if you're doing some algebra, blah, 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 and you get 3 equals 3. Okay. Again, it's weird. Something's wrong. There's no variable. Well, in this case, this is true. This implies that they're the same line, and I'm almost writing in the glare. Okay, they're the same line. So you have a weird solution. You go solution set braces, whatever, x comma y bar, and then you pick one of the equations. Okay, I'm just going to write one equation. Whichever equation you want, it doesn't really matter, because they're both the same. They're the same line. And so they have infinite number of solutions because they're on top of each other. Here's one line. Here's the other line. They're on top of each other. So they have an infinite number of solutions. But you just can't say infinity, because what about up here? That's not on the lines. Or over here, that's not on the lines. Okay, so you can say any point that's on one of the lines is on the other line. That's what this is trying to say in math talk. Okay, I'll pause. I'm not quite done. I'm just doing a real quick overview of chapter 5, all about systems. We had equations, 2 by 2s. We've practiced graphing, substitution, addition, elimination. And these are our types of answers. Any questions? Again, I understand I'm talking fast, and I wrote fast. Any questions about anything I've said, or does this contradict what you thought you heard me say earlier? Okay. Still in equations. Okay. We had 3 by 3 equations, and we have the 5 steps or 6 steps or whatever it was. Okay. If somebody wants more practice doing those, I can do them at the end of class tonight. Okay. There should be a whole lot of things to do this. Okay. So I'm not going to do it now, but 3 by 3 equations. Then we had inequalities. Nuts. Okay, we had inequalities. Okay, which is where we graph plus shade. And we have either dotted or solid lines. Now, I think in a nutshell, that's everything that I find important about chapter 5, systems. Okay, we have equations or we have inequalities. If they're inequalities, we have to graph and determine where to shade. If they're equations, then we find the point of intersection. And right there is an entire review of chapter 5. Any questions?
Nope.
Okay. I want to erase the board and go on to chapter 6. Again, if you have questions about wanting me to do some extra 3x3s so you can practice, I'll do those at the end of class. So you can stick around. Everybody else can go home if they wish. Okay, at the end of class, not now. That wasn't a go bye-bye. Okay. Keep in mind, tomorrow night I have some things that I absolutely can't teach via Zoom that I want to do in the classroom tomorrow night. Okay, because I'm assuming the classroom computer won't blow up. But we do have a chapter 5-6 quiz next week. So tonight we're going to start chapter 6. Tomorrow night, more chapter 6. So we should have plenty of time, chapter 6. And tomorrow we meet on campus at 6:35. I'll be there early, of course. And be sure to bring your mask. So all right, so here we go with chapter 6. Six 6.1 talks about something called a polynomial. Polynomial. And a polynomial is a bunch of terms that are separated by either pluses or minuses. So for example, 2x minus 7 or 3x squared plus 2y minus 8. Okay, or 5x squared y plus 3xy squared plus 2y plus 6, well, plus 6. We'll just leave it as that. These are all examples of polynomials. They're just a bunch of things that are separate, terms we call that are separated. Okay, dyslexia strikes. Okay, by pluses and minuses. All right, polynomial is the big giant umbrella term. We have special terms. This is called a binomial. Okay, bi means two terms. There's two terms here. Okay, this is called a trinomial because the prefix tri means there's three terms. Okay, this we just give up and we say it's a polynomial of 4 terms. We just give up. After 3, we give up. So we have special name for a binomial, that means 2 terms. Special name for a trinomial, that means 3 terms. After that, we give up. We say it's a polynomial of 4 terms or polynomial of 5 terms. Or sometimes we just quit and say, hey, it's a big ass polynomial. Okay, we don't have any names. We do have a special one like this, 2x or -7. These are both called monomials. And again, this is in the reading. If you want to remember in the homework, you can click on a link and it takes you to a book, an online book. And this is in there also, but we'll go over this. Now, some things you need to know. First off, okay, the term without a variable is called the constant. Think about what the word constant means. Think about what a variable means. Okay, a variable can change. Hey, what if x is 5? Then this is 10. What if x is 1? Then this is 2. So this term can vary its answer depending on what x is, because x is a variable. But the -7 will never vary. It will never change. And so because of that, we call the -7 a constant. It never changes. Now, be sure you say the -7 or the -7. Don't just say 7. Okay, so the -7 is a constant. In this one, the -8 is a constant. The 6 is a constant. This one, depending on how tricky you get, 2x is a monomial, but it implies 2x plus 0. So you could legitimately say 0 is the constant for this, or you could just say there is no constant. Usually, mom just says there is no constant. But sometimes mathematicians like to get weird and they like to remind us that, you know what, if something's not there, it actually is there if we just add a plus 0. Okay. Remember, mathematicians did a lot of drugs back in the 60s and 70s. Okay. So that's a constant. What else did I? Oh, the other vocabulary word you probably need to know is the number in front of the x is called a coefficient. Coefficient. So we would say on this binomial, because there's two terms, the coefficient of the x is 2. And the constant term is -7 or -7. On this one down here, the coefficient of x squared is 3. So the coefficient is 3. The coefficient of y is worth 2. And the constant is -8 or -8. Now, I'm not going to be real big on testing your vocabulary. I'm not going to have matching or something or where you have to tell me what these terms mean. But when you read directions or when I write directions up here, you do need to know these words. Okay? Because these are the building blocks for bigger ideas. So again, polynomial means a whole bunch of stuff either being added or subtracted together. If it's got one thing, we call it a monomial. If it's got two things, two terms, we call it a binomial. 3 terms is a trinomial. After that, we just say it's got 4 terms or 5 terms or, you know, whatever. We have the term constant and we have the vocabulary word constant and the vocabulary word coefficient that you do need to kind of know. Okay. I need to erase and talk about a few other things. Are we okay or not okay? Is anybody still writing that down? I can wait while you try and catch up with me. No? All right. Okay. Still within chapter 6.1, still within the idea of what's a polynomial, we have something that we call like terms. Okay. And like terms have exactly same variable. Can't stress enough the word exactly. I'll show you that in a minute. And when we find like terms, we either add or subtract their coefficients. So suppose we had 3x squared plus 5x minus 2. So we have a trinomial. And I want to add it with 7x squared plus 6. So I want to add a trinomial with a binomial. I want to add those somehow. Well, I know that 99% of you already know how to do this. Okay. And you can all do it in your head, and that's cool. But I just need to go over it once to remind you. So we look here for like terms. And in this problem, 7x squared, 3x squared and 7x squared are the like terms. And the minus 2 and the 6 are also like terms. The 5x, even though it's got an x, it isn't exactly the same as the other ones. They're x squareds. That's what the word exactly means. So you can add x squareds with x squareds, x's with x's, y's with y's, but they've got to be exactly the same variable. Okay, so mentally, what we do mentally, we think 3x squared plus 7x squared, comma, we think 5x, because it's nothing, comma, and we think -2 plus 6. Now, again, I said mental, okay, because you do not have to write this down, but you do have to think this. So when you're adding 3x squared and 7x squared, technically what you're adding is the 3 plus 7 of the x squareds. You add the coefficients, 3 and 7. So you get 10x squared. That was a positive 5x, so we say plus. It was implied to be a positive. So when we bring it down here, we write a plus sign. And -2 plus 6 is positive 4. So we bring down a positive 4. And that's our answer. So that's adding like terms, combining like terms. And again, if you had any algebra any time in your past life, which you're supposed to have, because this first part of the semester is supposed to be all review. Okay, you probably ran into that a whole bunch. Okay. Well, what happens if I give you this one? What if I gave you 7x squared minus 5y squared quantity minus 3x squared minus 2y squared plus 6. 7x squared minus 5y squared, that's one quantity, minus 3x squared minus 2y squared plus 6. Okay, I want to do this, or actually, you guys want to try it? Just take 1 minute. Okay, Every instructor has their own favorite way of teaching this. And I keep changing over the years. I like to think of this minus sign as distributing through. Remember, one of our first rules was to distribute to get rid of parentheses. So a lot of people think of this as not just a minus sign, but a -1. And they distribute -1 times everybody. So their next step would look like this. They'd say, okay, nothing's happening here, so I can drop the parentheses on this one. Okay, it's not being multiplied by anybody. They just were there to look pretty. I don't need them. But if I distribute the minus sign, minus times 3x squared is minus 3x squared. Minus times -2 is plus 2y squared. And minus times 6 is -6. Probably sneaking the -1 in here and distributing the -1 is the most common way that people have taught that. There's other ways to think it, but it doesn't matter to me how you get there as long as you get to this step. Now, mental, you're going to combine like terms. You're going to say, 7x squared minus 3x squared. And a -5y squared plus 2y squared and a -6. So mentally, you're going to scan this problem and you're going to say, oh, look, the 7x squareds and the 3x squareds are like terms. Okay, the 5y squareds, the y squareds here, and the y squareds here are like terms. So mentally, you're going to combine those two like that. Okay, we subtract the coefficients. 7 take away 3 is 4x squared. -5 plus 2 is -3y squared. And the -6 just comes down for the ride. And that would be your final answer. And I fully accept that someone, you guys need to know, we got some pretty high scores in this class. Okay, so I fully expect that several students in this class could jump from here to the answer in about 10 seconds, 5 seconds maybe. Okay, don't panic people about people getting better grades. In my grading system, it's possible that every person could get an A, and I don't care. Actually, I'd be really delighted. Every person could get an A, and that would be wonderful. I'm just telling you that several people have really high grades, like over 95%. Okay, so it's possible. Okay, I know some of you feel like you're overworked. This is more work than you thought, or whatever. But a lot of people are doing well in here. Okay, back to like terms. So here's addition of like terms. Here's subtraction of like terms. Okay, I have 2 more examples because mom likes to screw with us. So before I show you those 2 examples, any questions? Okay, then here's 2 questions that you might find on Mom. Okay. Suppose we write a function f of x equals 3x squared minus 7x plus 6, and g of x equals 3x squared plus 2y okay, plus 1. So remember, we call these functions. This was f of x, and it follows this rule. Excuse me, I'll make this 2x instead of 2y. Don't want to get too weird. G of x is 3x squared plus 2x plus 1. So mom is going to say, find f of x plus g of x. And number 2, find g of x minus f of x. So let's take a couple minutes and have you work both of those out. Okay, so what I did is, while the recorder was off, f of x was this polynomial plus g of x is this polynomial, so I expanded them out. Okay, this is f of x plus g of x. Again, combining like terms. I won't rewrite it now, but 3x squared and 3x squared are like terms. Also, 7x and 2x are like terms, and 6 and 1 are like terms. So when we combine like terms on the first one, our first answer should be 6x squared minus 5x plus 7. So that would be f of x plus g of x is that function, whatever that is. Okay. So again, down here, what are my like terms? Okay, 3x squared, 3x squared. Well, actually, I'm not going to do this. The first thing I need to do is distribute the minus sign. That's key. You've got to get rid of parentheses. You technically can't add or subtract these because of the parentheses. You had to get rid of them. Okay. We cheat a little bit, but you did. So this particular problem had no parentheses or no reason for parentheses, so I just can write it down again. But this one has a need for parentheses. The minus sign distributes. So we have minus 3x squared plus 7x minus 6. And this is, yeah, this is dying. Nuts. Where we go? Okay, so the first thing we had to do was decide, hey, there was no good reason for these parentheses because nobody is distributed into it. But there is a need for these parentheses because the minus is distributing. So we have to distribute the minus sign to get rid of the parentheses. When we combine like terms, the 3x squared and the minus 3x squared, those go away. They cancel each other out. The 2x and the 7x make 9x. And the 1 minus 6 makes a minus 5. So that would be the answer to those two problems. Questions? Okay. I don't hear anybody yelling. That was all in section 6.1. Vocabulary, combining like terms. There's a few other things in there, but I think you can figure the rest of them out. Those are the key ideas. Mom likes to add functions, just to throw them in there just to kind of remind you that functions exist and you can do some stuff with them. All right, here we go. We jump to 6.2 and life will get weird. So I'm going to start 6.2, get some rules up here, then we'll take a break for a few minutes. Okay, in chapter 6.2, we're going to talk about exponents. And we're going to start really simple, and then all of a sudden it's just going to go blow up, okay? And you're going to have rules up the yin yang, okay? And it's just not that hard, but it's going to feel hard until you practice this for a while. Okay, in an exponent, suppose we write 3 to the 4th power. We need some vocabulary. 3 is called the base. Now, this is going to be important both in this chapter, although you could probably get away with that knowing it, but definitely when we hit chapter 10, we're going to come back and revisit exponents again. Okay, and you do need to know that vocabulary. The bottom number is the base. This top number is either called the power or the exponent. Technically, there's a difference, but it doesn't matter. An exponent is shorthand, mathematical shorthand for repeated multiplication. Now, that's kind of important, okay? Because I'm going to give you a whole bunch of rules in a few seconds, and those rules only apply if things are multiplying together, because exponents imply multiplication. Okay, so when you write 3 to the 4th power, it's a shorthand for 3 multiplied by itself, a total of 4 times. Okay, a total of 4 times. And then if you actually end up doing this, okay, you should get 81, which is called the product, P-R-O-D-U-C-T. Product is the answer to a multiplication problem. So we start with an exponent term here, 3 to the 4th power. Our vocabulary is the bottom number, the 3 is called the base, and the 4 is either called the power or the exponent, doesn't matter. Okay, it means repeated multiplication, 3 times itself, a total of 4 times. Okay, and the answer, when you get that out, is called the product. Your calculator has a button on it. Some calculators have this button, up caret, like that. Where's my TI 36? Yeah, on the 36, in the left-hand column, you have an X to that button. So you could go, for example, 3, hit that button, and 4, and it'll see this as 3 to the 4th power, and it should give you 81. Should. Okay, I'll come back and we'll play with that later if we need to. All right, that's the basic idea of exponents. Now, there are some basic rules, 2 really simple basic rules. And I'm going to give them to you with no explanation. I'm going to use really bad teaching. It's shut up and memorize. I'll explain probably tomorrow night where these rules came from. Okay, it's not magic. But right now, the first rule is any number to the 1st power is itself. x to the first power is x. Okay, 5(2.31) quantity to the first power is 5(2.31). Any number to the first power is itself. Notice this rule is what we call bidirectional. It goes both ways. If somebody writes x, they mean it has x to the first power on it. Now, usually we don't need that. We don't care, but it's there if we need it. And occasionally we will. You'll see that later on. So these are called bidirectional rules because usually we see them go x to the first power is x. Well, it goes the other way. If you just have a plain old x, you can stick a 1 up there if it helps you. Okay, that's rule number 1. Rule number 2, x to the 0 power is 1. With one exception, any number to the 0 power is 1. And again, just hang with me. This is one of those shut up and memorize points. Okay. I'll show you, like I said, probably tomorrow night where this comes from. Any number to the 0 power is 1. Now, be careful. What if you have 5 times 372 to the 0 power? Well, the quantity is 1. So this becomes 5 times 1. So the final answer is 5. But the part that was being raised to the power is worth 1. Be careful, pay attention. Okay. For what it's worth, I'm going to give you a problem like this, definitely on the quiz, definitely on the exam. 3x squared, y to the third quantity cubed times 2x squared y to the fifth quantity squared times 15x to the fourth y quantity to the 0 power. That's going to be a problem, and hopefully by tonight this won't even be an issue with us. We can do this. But the key that screws everybody up on this problem, okay, is they fail to see that this whole quantity becomes 1. Okay, now don't panic on this. I'll show you how we're going to do these later. Okay, it's not hard. But the key here that I'm trying to make is this quantity right there, because it's being raised to a 0 power, that whole quantity becomes worth 1. And remember, we're all multiplying here. Okay, so essentially it drops out because 1 times anything is itself. All right, so those are our basic rules. Then we're going to get to intermediate rules. Wait a minute, before I erase, questions. Anybody need anything for clarification? Those are very, very basic rules. Any clarification needed? Okay, then I'm going to give you the intermediate rules of exponents, but I'm going to give them to you in the way that you will actually use them in a problem. Okay, I'm going to give you a first, second, third, fourth rule. The way the book usually, any book usually introduces it is they first introduce the third and fourth rule. Then after you've practiced that a while, then they go back to the second rule. And after you've practiced that a while, they go back to the first rule. But when you get a big old problem, okay, you have to do them in the order that I'm going to show you. So I get really kind of frustrated. I understand why books teach it the way they do. I understand it. But they're giving you the wrong idea. Okay. This is like the PIMDOS of exponents. What do you do first? What do you do second? What do you do third? So the first intermediate rule is we're going to distribute to remove any parentheses at all. So for example, suppose you have 3x squared y quantity to the 5th power. Okay. The first thing you're going to write this as 3 to the 5th power times x to the 2nd to the 5th power times y to the 5th power. So what I just did here is this whole quantity was being raised to the 5th power. So you distribute the power to each piece of the quantity. Okay. And don't panic if it looks ugly like that or that. Don't panic yet. Okay. It's not that bad. Then the second rule that we have is if you have a power raised to a power raised to a power, let me write that nicer. Okay. Then you multiply the powers, but you keep the base. So you scan your problem and you say, well, let's do this. Let's say I have 2x to the 5th, y to the 7th being raised to the 3rd power. Well, the first thing I do is I distribute the power in. So this is 2 to the 3rd times x to the 5th to the 3rd times y to the 7th to the 3rd. And that was rule number 1, distribute to get rid of the parentheses. Rule number 2 says, do you have a power raised to a power? Well, yeah, I do right there. I have a power raised to a power. The 5th power is being raised to the 3rd power. So the rule says multiply the powers, but keep the base. So this will become x to the 15. 3 times 5 is 15. Multiply the powers, but keep the base. Now move to the y. That's a power, 7, raised to another power, 3. That's a power raised to a power. So we multiply the powers and we keep the base, y to the 21. Now, this is just arithmetic. 2 to the 3rd power is just 8. You can work that one out. You can use your calculator. You can use your fingers and toes. That's up to you. 2 to the 3rd power, remember, means 2 times 2 times 2. 2 times 2 is 4 times 2 is 8. It is not 6, although people will try and do that. All right, put it all together. Because we're sophisticated mathematicians, we don't want a bunch of dots there. So we write this as 8x to the 15, y to the 21. And that's your final answer. Okay, so we've got more to do. Hang on. First was distribute to remove any parentheses. So that's kind of what I did here. I distributed. Notice something. I distributed the 3 to the 2 and to the x to the 5 and to the y. For some reason, Students don't want to distribute the 3 to the 2. I don't know why, but they don't. They just blank out on it. I mean, just like it's not there. I don't understand. Okay, let's try you guys this one. Your own example of these two rules. 3x to the 9, y to the 6, z to the second, quantity to the 4th power. 3x to the 9, y to the 6, z to the second, whole quantity raised to the 4th power. See if you can do that. I'll pause it for just a second. Okay, so the first thing I want to do is distribute the 4. So this would be 3 to the 4 times x to the 9 to the 4 times y to the 6 to the 4 times z to the second to the 4. So that was the first rule. Distribute the power to get rid of the parentheses. So everybody got hit with this 4. Boom, boom, boom. Now, for what it's worth, 3 to the 4 is 81. We did that over here. Okay. Power raised to a power right here. Power to a power. Power of 9 raised to the power of 4. Multiply the powers, keep the base. X to the 36. Keep the x. Okay. 9 times 4 is 36. Keep the y. 6 times 4 is 24. Keep the z. 2 times 4 is 8. Put it all together without the silly dots. 81. X to the 36. Y to the 24. Z to the 8. And that's my answer. Questions? All right, let's take about a 3 or 4 minute break right now. Stand up, stretch, whatever, go to the restroom, whatever. I'm going to find out if my dog is still stuck outside. I'll be back in a second, about 3 or 4 minutes. Okay, so take a break. Okay, so those are our first two rules. And when you see a exponent problem, this is how you attack it. First, you get rid of parentheses. Second, you look for power of power. Okay, then we come down here to the third step, which is if they are same base multiplying. Okay, you keep the base and you add the powers. So what am I talking about? Well, I'm going to make it a little bit more complicated. Suppose you have 3x to the 4th multiplied by 5x to the 10th. So suppose we have this as an example. Technically, what you do is you rearrange this into 3 times 5, x to the 4 times x to the 10. Now, again, this is mental. Those of you who have seen exponents before, who are comfortable with them, or maybe after you've done a few problems on the homework, you go, yeah, I got this. You can do most of these in your head, and that's okay. Okay, but mentally you rearrange it. So you got number times number, 3 times 5 is 15. And according to the rule, we're multiplying with the same base. So we keep the base, x, we add the powers, 4 plus 10. So the final answer is 15 x to the 14. That's our final answer for this problem. Okay, let's do another one. Suppose we had, new example, 2x squared y to the third multiplied by 5x to the 7 y to the, I don't know, 6. Okay, I'm going to walk you through it. Maybe I'll give you 30 seconds to think about it. I'll give you some more to try in a moment, so don't panic. You'll get plenty of work. So again, mentally, we get 2 times 5, just number times number. Then we put together x squared times x to the 7, x with x, y to the third times y to the 6. Again, the key here is same base. That's why we're regrouping the problem. We're getting number times number, base times base, base times base. Okay. Yeah, I'm doing it right. Okay. So this becomes 10. 2 times 5 is 10. This becomes x to the 9. 2 plus 7 is 9. Keep the base, add the powers, and this becomes y to the 9. Keep the base, add the powers. Yes or no? That okay with everybody? Can you think of what's the one, what are the, I guess, what's the one place that people are going to screw up?
Probably adding the powers.
Yeah, what happens, good call. What happens is people get confused between, okay, when do I multiply the powers and when do I add the powers? And that can totally change a problem. When do I multiply the powers? When do I add the powers? So if I were you guys, I would make a little cheat sheet, something on your note cards that you can study that shows an example like this. This might be a good problem of when you added the powers, and actually write, keep base, add powers. So you write yourself a note here. That would be something that before a test or a quiz, okay, I would be looking at my notes going, yes, yes. Okay, I know that one. By the way, speaking of test or quiz or something like that, even if someone says you can't use notes, there is absolutely no reason you can't do what's called a brain dump. And that is, you've got all these ideas in your head, all these formulas, okay? And you can put them on paper. You can show me, you can say, hey, Foster, look, this piece of paper is blank. I want to put all my formulas on it. As long as you start an exam or a quiz with no problems on your paper and then, or no notes ahead of time, and then put your own notes on there, that's good test taking. That's not cheating at all. And I can't think of one instructor that wouldn't allow you to do that. Okay, if they say no notes, you can't have notes on this exam, or whatever they say. Okay, That's fine. That's their prerogative. But you have the opportunity to have as much stuff memorized as you can and then dump it on the paper. Okay, so you have it to refer to. That's just plain good test taking skills. Yeah, so this would be this would be a good example here. I think this would be a good example. Maybe this one, I don't know, whichever one of these. All right, I need to erase the board. Any questions before I erase? So let's try these. Number one, 5x squared y to the third quantity squared times 2x y to the fifth quantity cubed. Number two, negative 3x to the fifth y to the third times 2x to the 7y quantity cubed times 5xyz quantity to the 0 power. Okay, I'm going to knock through these rather quickly, and then you can yell at me if you need me to redo something. Okay, so first thing I do is distribute. So 5 to the second, x to the second to the second, y to the third to the second. 2 to the third, x to the third, y to the fifth to the third. So this is 25, x to the 4, y to the 6. This is 8, x to the third, y to the 15. Regroup. Again, I'm going to write mental here. 25 times 8, number with number, x to the 4 times x to the third, y to the 6 times y to the 15. I believe that's 200. Yeah. X to the 7, y to the 21. All right. I skipped some steps and I went very fast. Questions? Anything you want me to explain? Again, do again. Slow down, whatever.
Where did that 8 come from?
2 to the third.
Oh, okay. I see.
You okay with that or not?
Yes.
Okay. Anybody else? You sure? Because there's a homework problem and there's the next week quiz problem right there on this section 6.2. Okay, cool. All right. So we move to here. The first quantity has no power on it. So I just bring it down. Second quantity has a power, so 2 to the third, x to the 7 to the third, y to the third. The third quantity has a big fat 0 power on it, so it turns into a big fat 1. Rearrange it. You have negative 3 times 8 times 1. The 8 came from 2 to the third. You have x to the, whoops, I'm sorry. Slow down, Foster. I'm skipping too many steps. This is -3, x to the 5th, y to the 3rd. 2 to the 3rd is 8 again. Power to a power is x to the 21. Y to the 3rd times 1. I'm sorry, I was going too fast, skipping too many steps. So mentally, you have -3 times 8 times 1 times x to the 5th times x to the 21 times y to the 3rd times y to the 3rd. So put everybody together. This is -24 times x to the 26 times y to the 6, and that's my answer. Questions on either of those problems? Okay, now tomorrow night we're going to come back and revisit these rules and make them a little bit trickier. Okay, but not much, so don't panic. We'll come back tomorrow night. There's more we can do. There's 4 rules. Remember, I give you the 2 basic rules, and then I give you 3 intermediate rules. Well, there's actually a 4th intermediate rule that you don't need yet. Okay, it's not in the homework yet, so I won't give it to you until we need it. All right, so I need to erase, move on to something else. What I want to move on to is section 6.3, which I'll write up here in a second. It's called multiplying polynomials. We want to multiply them together. We already know how to do one of them. This was a monomial times a monomial. And what did we do? We regrouped it with number times number, same base times same base, same base times same base. I'll show you that, okay, but I'm not going to do a lot of examples of that. The funner stuff, which despite TV commercials and billboards is not a word, funner. Okay. So we're going to, this is chapter 6.3. We're going to multiply polynomials. And you know what? I'm just going to skip it. I'm going to tell you that it's a combination of distributive property, plus your rules of exponents. So suppose we had, for example, 3x squared times the quantity times the quantity 5x squared minus 4x plus 3. Okay, so again, parentheses kill us. We don't like them. So we have the distributive rule. Again, I accept that some people can do this entirely in their head. I'm not going to show you. I have to show you how. I have to show it to you on paper. Okay, so here we go. We're going to distribute. We have here 3x squared times 5x squared. Distribute here minus 3x squared times 4x. Distributed here plus 3x squared times 3. So what we've done is we distribute the 3x squared to each term inside. And notice we keep the minus and the pluses. Now, each one of these becomes a baby problem that we just got done erasing over there. This becomes 3 times 5 is 15. And this is multiplying with the same base. This is rule number 3. Rule 3. Okay, you keep the base, you add the powers. 4. The minus sign comes right down. Again, keep the base. Well, 3 times 4 is 12. Keep the base, x, add the powers. Now, please watch carefully. There's a 3 there. Where in the world did the 3 come from? Because 2 plus nothing is 2. How did I get a 3 there?
From 4x.
What about the x?
Is the first rule.
4x.
Right. Remember, when somebody walks up to you and says x, what's it really mean? It means x to the first power. So when you go back here, when I wrote 4x, it means 4x to the first power, so that when you add the powers, 2 plus 1 is how I got a 3. And a lot of people forget that invisible 1 there. And that was one of the, remember the 2 basic rules I had, x to the first and x to the 0 power? I had it right here and then I erased it. Well, that's what we're using right there. X to the second times x to the first is x to the third. Okay, bring down the plus sign. This is 9x to the second, and you're done. That was it. And you can't add these together because none of the variables is exactly alike. They all got an x, but this is an x to the fourth, this is an x to the third, this is x to the squared. They're related to each other. It's like they're cousins, okay, but they're not exactly alike, so you can't go further. Yes or no? You want to try one more of those? Okay. The thought is overwhelming. Cool. Let's be a little bit weirder. 2x squared y to the third times 5x to the fourth y to the second plus 3x to the third y plus 6. 2x y to the third times the quantity 5x to the fourth y to the second plus 3x to the third y plus 6. Take a second. So we're going to distribute this mess to here, and then to here, and then to here. I'm going to write everything out. So we have 2x to the second, y to the third, times 5x to the fourth, y to the second, plus, then we distribute again, 2x to the second, y to the third, times 3x to the third y, plus 2x to the second, y to the third, times 6. So I've distributed the 2x to the second y to the third to each term inside. So that's the first thing I said here, distribute. And then I said, go back and use your rules of exponents. Usually 99 times out of 100, it's going to be rule number 3. Keep the base, add the powers. Rule 3. Okay. So 2 times 5, that's just normal 10. X squared, x to the fourth, keep the base, add the powers, x to the sixth. Y to the third times y to the second, keep the base, add the powers. Plus, again, the pluses and the minuses just come down. Okay, this becomes 6 x to the 5. Be careful, this is y to the 4. Again, it had that invisible 1 there on the y. And plus comes down, final answer 12, x to the second, y to the third. And that is my final answer. Yes or no?
Yes.
Yes.
Okay. Now, I need to erase the board because my next few examples are going to get, there's more than one way of doing it depending on what you've been taught, and they get kind of messy. Okay. So I need to erase the board. Anybody going to yell at me if I erase the board? No. All right. All right. We want to do more complex multiplying of polynomials. I'm going to start with a pretty easy one right now. Suppose we had 2x plus 3 times, I don't know, 5x squared minus 7x plus 6. Okay, this is a binomial times a trinomial. Now, I'm going to show you 2 different ways to do it. You're going to get the same answer either way. In the end, I don't care how you do it as long as you get the right answer. So the first way is called a matrix or a box. So on the outside, you put a 2x and a 3. And on top, you put 5x squared minus 7x and a 6. I'm sorry, 6. So it's a 2 by 3 box. There's 6 boxes inside there. And then you start doing all of the multiplication. Now, the cool thing about the box is you can do it in any order you want. Okay, 3 times 6 is 18. 2 times negative 7 is negative 14 x to the second. I'm trying to show you that you can skip around. I don't recommend it. I recommend that you be neat and organized. But the box is really rather cool. You take the 2 times that number, put the answer there, times that number, put the answer there, times that number, put the answer there. And each time you're still doing rule 3. So 2x times 5x squared is 15x to the third. 2x times 6 is 12x. 3 times 5x squared is 15x squared. 2 times 5 is 10. Last thing I checked. I just screwed up there, guys. 2x times 5x is 10x to the third. Be careful, I screwed up originally. 3 times negative 7 is negative 21x. So that's called a matrix method. So we multiply, we now look for like terms. We're not done. So highest power is 10x to the third. Okay. Next highest power is x to the second. So I look here. And I have positive 15 minus 14. So that makes plus 1 of the x to the seconds. Okay, the next one are right here. And what's really cool is they'll always be on that diagonal with each other. So you can look for them that way. Negative 21x, 12x is negative 9x. And then the 18 just hangs around here as a plus 18. Now that's called matrix multiplication for polynomials. It's a nice way of keeping your work organized. It's a great way to keep your work organized. The way this is traditionally taught. Okay, notice my emphasis on the word tradition. If you go to a basic high school classroom or maybe a first time in this, they do the distributive property. They say, oh, 2x squared times everybody here. So if we do that, 2x times that is 10x to the third, 2x times 5x squared, 2x times minus 7 is minus 14x squared, and 2x times 6 is plus 12x. And then they usually teach, now we multiply by the 3 times everybody in the back. Okay, so 3 times 5x squared is 15x squared. 3 times minus 7 is minus 21x. And 3 times 6 is plus 18. This is how most teachers teach it in the beginning algebra class, is they teach this as a double distributive. First, you distribute the 2x to everybody in the back. Okay, so I'll put this in red. This is when I distributed 2x. And this is when I distributed the 3 to everybody. Now you look for like terms. By the way, notice something. This line here in red and this row here of my table or my matrix is the same. This line in green, the second row here is the same. So these are matching each other. They're just different ways of organizing your work. So anyway, if I add like terms, 10x cubed doesn't add to anybody. Minus 14x squared plus 15 is plus 1x squared. 12x, take away 21x is minus 9x. And then the 18 hangs around. 18, dope, 18. And I got exactly the same answer. The only suggestion I would write is instead of 1x squared, we just write it as x squared because it's more sophisticated. Questions? So I've done this problem 2 different ways. There's actually a third way. I'm not going to show you tonight. Maybe we'll hit on it tomorrow night. Most students, most beginning students tend to like this better, the box, the matrix, because it organizes your thoughts and your work. Okay. Other students who've been doing this for a while, they like this because it saves you some time and some steps. Bottom line, I don't care as long as you got this answer. Okay. I'll have you guys try one on your own. You guys ready? I don't hear anybody yelling at me that I don't understand, I don't get it. So I'm assuming that we're okay. All right, here we go. 5x minus 3 times 3x squared minus 9x minus 4. 5x minus 3, quantity, the binomial, times the trinomial, 3x squared minus 9x minus 4. Okay, pause, do it either way. Okay, so I'm going to start with the matrix or the box. I'm going to have a 5x and a minus 3 here. I'm going to have a 3x squared, a minus 9x, and a minus 4. So then we just start multiplying. 5x times 3x squared is 15x to the third. 5x times minus 9 is minus 45x squared. 9x, I should have said. 5x times minus 4 is minus 20x. Negative 3 times 3x squared is negative 9x squared. Negative 3 times negative 9 is positive 27x. And minus 3 times minus 4 is plus 12. Okay. You guys kind of catch up. Any questions about how I multiplied what I was thinking? How did I go from 3x squared and 5x to 15x cubed? What did I do? Are you sure you understand that for each one of these boxes? Okay, then we start looking for like terms, x cubes. There are none, so it's 15x to the third. Okay, we look for x to the seconds. Every like term should be like in diagonals like that. So negative 9 minus 45 is negative 54 x to the second. And we look for x's. There they are there. Positive 27x, take away 20 is positive 7x. And then the plus 12 just comes down. And that is your answer. Okay. Does anyone want me to show it the more traditional way where you distribute the 5 to everybody and then you distribute the minus 3 to everybody? You should get the same answer. Does anybody want me to show it the more traditional way? Okay. Then just to mess with your brains, just because I love you so much, x squared plus 3x plus 2 times 4x squared minus 2x minus 3. A trinomial times a trinomial. Give you a hint. If you make a box, it should be 3 things this way for the first trinomial, 3 things this way for the second trinomial. See if you can do it. Okay, so while the recording was turned off, the recorder was off, I redrew the box, put my first polynomial here, second polynomial there. It doesn't matter who's on top and who's on bottom. Okay, in the end, the answer is the same. So we get, this would be 4x to the fourth. I'm going to just multiply by x squared minus 2x cubed minus 3x squared. So that's multiplying x squared times each of these things on top. Then I multiply 3x times each of these things. So that gives me 12x to the third. Remember, when we say 3x, there's an implied 1 there. Or negative 2x, there's an implied power of 1, if you need it. If you don't need it, you don't have to write it. That's up to you. But 3x times x to the 4x squared is 12x to the third. 3x times that is negative 6x squared. 3x times that is minus 9x. 2 times that is 4x to the second. 2 times that is negative 4x. 2 times that is negative 6. Okay, I will pause for just a second while you guys catch up and check to see if your work matches my work.
They're not supposed to be 8x instead of the 4x.
Yes, you're right. Thank you. That's why we pause. Did I screw up anywhere else? Thank you. Okay. So let's look. We have 4x to the fourth. Now, our like terms will almost always be on that diagonal. So 12x to the third, take away 2x to the third is plus 10x to the third. Okay. Another diagonal, my x squareds. This is like a word search, isn't it? Okay. 8x squared, take away 6 is 2x squared. Take away 3 is negative 1x squared. 8, take away 6 is 2. Take away 3 is negative 1, and this was the x squareds. Okay. My x's are right here. Minus 4x minus 9x is minus 13x. Minus 4 minus 9 is minus 13. And the minus 6 comes down. And that's my final answer. Okay, questions? Okay, like I said, tomorrow night, I'm going to be doing things in the classroom that can't be done easily on my Zoom. Okay, there's some things that will help you a lot. I'm also going to finish off chapter 6. Come loaded with questions tomorrow night, guys. Do you want me to do a 3x3 again? Do you want me to practice that? Okay, is there something in chapter 5 that you want me to go over? Okay, all right, hasta mañana. If anybody wants to stick around and have me do a 3x3 or anything else, I'll be happy to. See you later. Bye-bye.
Bye-bye. See you tomorrow.
Professor, are we doing anything for attendance tonight?